All right, here we are. Hey, everybody, how you doing? It is Serverless Office Hours. And he, say hi.
Hi. Hello.
Adam, say hi.
Hello.
Sorry, that seemed very commanding. It didn't mean to come out that way. So I want to welcome Adam and Anahit. And Adam, yours is Oathead. Where did that come from? I have to ask you.
Man, it's like back in the day of playing like Quake and Team Fortress and stuff, everyone had like funny names, and I had like a bowl of oatmeal, and somehow like Oathead was the gamer handle. And then, sometime early in the Twitter thing, people were like, you should join Twitter. And I was like, I don't know, so it just stuck, and now I'm stuck with it.
I was really expecting more depth there. I'm not gonna lie. I was expecting something really deep and probably life-changing, but no. All righty. So first we're gonna go. Annie, tell us about you and what do you do? Who are you?
Yeah, so, well, my Twitter handle is pretty straightforward, very creative, right? So I'm actually based in Finland, but I'm originally from Armenia, and I came to Finland like around, 17 years ago, came to study for my second master's in computer science, and I kind of never left. So here I am now, and I'm currently working as a lead cloud software engineer at a company called Solita, which is one of the Finland's largest digital transformation companies. And we have also offices in other 5 countries in Europe. So I have been working here for a pretty long time now, and have been doing a lot of different stuff, full stack development for over a decade. Have done it all pretty much, like backend, front end, integration, data engineering, and started on-prem, then moved to AWS, and thank God never needed to go back to on-prem ever since. So yeah, I'm an AWS data hero, which is actually a huge honor, and that's great.
Yeah, that's a big deal. That's cool.
Yeah, that's cool. Unfortunately, I haven't met any of the heroes in person yet because had to skip the event this year, but hopefully next one. And aside from that, yeah.
I was gonna say, I feel we're traveling again, so I think you're gonna get to.
I hope so.
That's probably the Eric Johnson optimism, but it's gonna happen.
I really hope so. Yeah.
Me too.
Kind of this year, though, I had other kind of reasons not to travel. I'm also now a full-time mom of a 3-month-old baby boy. So that was, thank you. So that was the main reason for me not to travel this year.
Yeah.
And the baby boy is now upstairs with his dad. So if he starts screaming at any point during this recording, I have warned you. Sorry.
Okay. Yeah. If you run out, we understand, and we bless that and understand. So, Adam, you're one of us, or you're an Amazonian. Tell us about you.
Yeah.
Well, hey, hang on. There's a Sam on your shirt.
Oh yeah. This is.
I want that.
I'm proud of this one. It says. Well, I can't grab my own shirt, but it says we got Sam there, and then on this side it says Serverless MVP for some stuff that I did a while back. But yeah, you gotta love the Sam and rep the Sam.
That's right.
But yeah, I'm a specialist solution architect, so I focus on serverless services here at AWS. I've been at AWS a little over 7 years, so I have the distinction of being the only serverless specialist solution architect that was doing this before Lambda existed. So I remember was here for the Lambda launch, and remember being like,
wow, you're an old fart.
I am.
So, yeah. I mean, I am too, obviously. Sorry, and you have to be with us old people, but yeah, that's awesome. I was with a partner when Lambda was announced, and I remember just staring at the screen and going, "Why would you do it any other way?" That just clicks. So. Very cool. Well, welcome both of you to the show. You may have saw I was a little distracted. It looks like we had some problems on Twitch, but we are up and running now. Verified. Thank you. I think Jones, Zachariah, Noel, always there. He was letting me know. But yeah, we are up on Twitter or Twitch, LinkedIn, and YouTube. So I think we're good on all of them. So, all right. Well, this is Serverless Office Hours. This happens every Tuesday at 10 a.m. Pacific time. What time is it for you, Annie?
It's 9. Oh, sorry, 8 in the evening.
8. Okay. All right. So that's not horrible. Okay. All right. So it's not
No.
yeah.
It's
I've
pretty
gone
okay.
I've gotten up and done presentations at 2 a.m. for the other side. So it's always like, whoa, so, but this happens every Tuesday. And today we're going to be talking about a new feature that came out at the end of last year. And that is AWS Lambda filtering. Or filtering for AWS Lambda. Now, I'm going to let one of y'all. I think Adam, you've got a little bit some slides you can show here. Let's kind of give them an idea of what we're talking about, and then we're going to jump into a demo. And you have a lot of background with Kinesis, obviously. In fact, you're doing it real quick. I'm going to take a pause here. You have a class or lesson. What's the right word that you've built on
online training.
An online training. That is much better than class or lesson. Yes, online training. And I'm going to post that link in a little bit. But is this somewhere where that filtering can be used?
For sure, yeah. And the online training is actually next week on O'Reilly platform next Wednesday. So everybody interested in how Kinesis works can join us there. But yeah, so basically filtering can be used with Kinesis and DynamoDB streams and also SQS. Of course, I'm most interested in Kinesis, but
of course, yeah. But it does. We have to, it does do others as well. So, Adam, I'm going to turn it over to you. I'm going to bring up your screen if you're ready.
Yeah, I'm ready.
I'm going to be quiet until I'm not. So here it is. I turn it over to you.
Cool. Yeah. So thanks everybody for taking the time. So yeah, we're going to talk about this new feature that is event filtering for Lambda event sources. As Anahit mentioned, it works for using Kinesis as a event source, DynamoDB streams, and then also SQS as well. And so logically, you can kind of think of it as fitting here, right? So you've got data producers on one side writing some data into Kinesis, and then you set this filter that basically says what type of messages, right, based on the payload, which messages you want to go to your Lambda function. And it takes care of filtering those out and sending them to the Lambda function. And then the Lambda function gets invoked with a batch of those records the same way it would with the streaming event source. So this is really cool because it just can cut down on the number of messages that your Lambda function has to process, just kind of further, saving you money, right? I love streaming event sources for Lambda because there's so much that Lambda does for you, right? So if you think about consuming a Kinesis data stream, normally you need to run code that is kind of polling Kinesis and keeping track of where you've read in the stream and then processing the messages. With Lambda, as the consumer, the Lambda service takes care of doing all of that polling for you. So you don't have to pay for the compute to do that polling of Kinesis, to keep track of how far you've read into that Kinesis stream. And now with this, you're again just getting more efficiency out of it because Lambda will do the filtering for you as well. Some cool things about this, it uses the same pattern matching as Amazon Eventbridge. So the syntax of kind of how those matching rules works the same as Eventbridge. So if you're already kind of familiar with that, you'll be right at home, writing these filtering rules. For a single Lambda function, you can define up to 5 patterns that you want to match against. And this does, support Kinesis, DynamoDB streams, and SQS. There's a blog post link there that we'll share as well. And then this is an example filter over here from that blog post. And I'll do a demo in just a little bit to kind of talk through that in more detail. Go ahead. You wanted to say something, Eric?
Well, no, I was just going to say, sounds good. And I'm posting the blog post right now. So it'll go to all channels coming out there. So real quick, I want to I'm going to ask you here. So we've all done filtering inside our Lambda code, right? So up until now, we have said, okay, everything that comes in, I have to inspect it. Is it what I wanted? Now, this filtering happens before the Lambda is invoked, right? So it decides whether the Lambda should be invoked or not. Is that correct?
Correct.
Okay,
Correct.
alrighty. Which is a huge, obviously, money savings there. Because I know I've written a million of them. One of my first ones, of course, was the take the image, modify it, drop it back in. Then, of course, I dropped it back into the S3 bucket, created the loop we all love to see and on our billing. Keep laughing. We've all done it. So but yes, that filtering, it's beautiful. I mean, the idea of being able to say only invoke on very specific reasons, and so it saves that invocation. Now, does that happen at the Lambda service itself?
Yeah. So think of it as the Lambda service is polling that data source, the Kinesis data stream, DynamoDB streams, or SQSQ. The Lambda service is doing that polling for you to see if there's new messages, and then it's applying that filtering. And then it's invoking your Lambda function, assuming there are some messages that match that filter criteria. That the great thing is, right, if there's a bunch of messages, but none of them match your filter criteria, it's not going to invoke your Lambda, right? And so the Lambda service is doing all of that polling and applying that filtering. Okay.
So a couple questions we had come in. I have another question, but I'm gonna wait and see if y'all answer it first. Go down the road here. So first question we had, I'm gonna go back up here, and either one of you are glad to jump on this, or we can say we'll jump on it later. But we had a question come in, said, is SQS more cost effective than Kinesis? And you have a smile on your face. Do you have a thought on this?
Well, the thought is that is a very common question, and actually people have this, in a way, bias that SQS is the cheap service and then Kinesis is the expensive service. And I would say it's mostly because Kinesis doesn't have the free tier support yet, at least. So you won't have anything for free with Kinesis. You will start paying right away. So that's one reason. And don't get me wrong, it's not a cheap service for sure, but I think there is some sort of a sweet spot in the amount of data. When the amount of data gets large enough, then Kinesis will actually cost you less than SQS. So it depends on your purposes, kind of what you use it for.
Yeah.
Well, and I think something you have to think about on that, I agree wholeheartedly, and I would add, right tool for right job, right? I mean, while there is overlap in those, they are different services, right? One is more, and so, SQS batch up and store it up, and Kinesis is that streaming idea. And again, there's a lot of overlap, but when would you kind of lean one towards the other?
And that's actually a very interesting question, because that's something I'm thinking of constantly. And especially during the past couple of years, I think I had this feeling that the messaging services are and the Kinesis are getting kind of closer together. They are in a sense kind of converging into, because there are constantly new releases that make them closer and closer. And even if you think SNS and Eventbridge as well, it's kind of they all go in that category, because we have very similar features now with the filtering and with the partial error handling for SQS, which we used to have for Kinesis. And then I think a couple of years ago, there was this batch window for SQS, and batch size was increased to the same 10,000 that Kinesis has. So they kind of work this. So it's kind of, interesting how you said that they are completely different services. Yes and no, because they are a
great Venn diagram, right? I mean, there's certainly overlap. Yeah,
exactly.
Yeah,
but you have to think about there are differences, I think, in throughput. So you have to think about your throughput requirements. There are differences in that sense. Then there is a difference in record size that you can send to Kinesis versus SQS. With SQS, I think it was 256 kilobytes. Correct me if I'm wrong.
Yes, correct.
And with Kinesis, it's up to 1 megabyte. So it's kind of depends what data you want to send. Then there is issues like ordering. So do you want to get out of the box ordering? With Kinesis, you get shard level ordering guarantee. And with SQS, for example, you have to have FIFOs for that. Also with the consumers, I think if you want to have multiple consumers versus like single consumer, custom consumers, or like service integration. So there are all these kind of things that you have to consider, which usually play much bigger role, in my opinion, than the price itself. So it's kind of how easy you can integrate those services using. And actually, Kinesis is not even considered an integration service nowadays. It's analytics service, but it's kind of, you can use it, and I have been using it as a service integration service very successfully. So, I mean, you have to consider all the facts that go into it.
Yeah, well said. I agree wholeheartedly. So, all right, Adam, I'm going to turn. We have some questions coming. We have a lot of questions coming in. So, I'm going to give you a little time to present, but prep yourself. There's some questions coming in.
Cool. Well,
yeah, go ahead and give us some more.
Cool. Yeah, maybe we'll answer some of them here, but yeah, happy to dive into questions. One thing that I wanted to bring up is, like the kind of where the event filtering happens in relation to some other features, mainly batch size and batch window being applied. So a little bit of kind of review on what batch size and batch window are. These are part of the configuration of your streaming event source. And batch size is really a maximum batch size. So you can say, I never want to get more than 100 messages sent to my, Lambda function. But if, Kinesis has some messages and Lambda pulls those messages and it only has a batch of 50, but it's ready to send, it's going to send you that batch of 50, but you're never going to get a batch bigger than 100. And then batch window is if you really want to avoid smaller batches, but latency doesn't matter to you as much, you could set a batch window of 30 seconds. And what that'll do is that batch window will wait, and it basically is like a union of those two settings, right? So either when the batch size is full up at your limit of 100, or you've reached that batch window of 30 seconds or whatever you set it to, then it's going to send you a batch of messages. And both of those calculations are done after the event filtering. So just again, like that making things more efficient, right? It's like doing it in such a way that it's nice.
That's pretty smart. I'm not going to lie.
Yeah.
That's so clever.
So some cool interactions there between those existing features and this new feature. When we're talking about kind of SQS and, Kinesis and some of the differences between them, and one of the differences that, I often talk to people about is just the way they work in terms of, Kinesis is an immutable data store, right? So once you add records into Kinesis, until they age off the stream and disappear, they're always there. And you're able to go back and look at them, read them, do whatever you want. The fact that your Lambda has processed them doesn't delete them, right? Whereas SQS, when your Lambda has processed those messages, they are deleted from that SQS queue. And so you do need to, go in eyes open if you're going to use event filtering with SQS to realize those messages that are not matched by your filter are basically deleted without being processed, right? Because they're not sent to your Lambda function because they've been filtered out, but they are marked as basically successfully processed. And
Can I ask a question, Adam?
Yeah.
Because that's something I came across as well, and it kind of sounds scary that things are deleted. And at least I didn't find any mentioning about any metrics or any place where you could actually see that things were deleted. So is there any place, because it sounds really hazardous if we don't even know that they were deleted, they came and they disappeared, and that was it.
Yeah. And today there's no metric to look at as well. And so what I really recommend is that if you're going to use event filtering with SQS, you really use it in this type of scenario where you do a fan out from SNS to multiple SQS queues and have at least one of them that isn't, filtering, so that you make sure kind of every message is processed. And, maybe there are edge cases where, you're very sure you don't want those messages, and you kind of don't do this, but for safety's sake, this is sort of what I recommend.
So this is interesting, and I hadn't thought of that, and that's a really good point. So if it goes into SQS and it does not match the filter, then it is triggered or it's tagged as, you are no longer needed. See you later. And I know that. What else would you do with them, right? I mean, that makes sense. That's obviously what you do. So this is kind of that idea of always save your raw data before you do anything else. Save your raw data, then you can run your event filtering. If you were to do, and I don't want to spoil the next slide, but in Kinesis, you could just have multiple consumers off this, right?
Exactly.
Okay. And do the different consumers have different filters? Am I jumping ahead?
Absolutely. Yep.
Okay.
Absolutely.
All right.
Yeah.
All right.
And so, man, Eric hadn't even seen this slide, but he kind of set me up for it, right?
What's up? That's how good I am at hosting right there.
So what I'm going to show you in a moment from a demo perspective, I actually did it with DynamoDB and DynamoDB streams. But what I did is basically built what I would recommend as like a great starting point for anyone that wants to play around with filters, which is as you're kind of developing your filter patterns and kind of what you want to filter out, what I recommend doing is having 2 Lambda functions subscribed to the event source, and have one of them where you're applying that event filter and have one of them that has no filter. And that way you can get a feel for, how many events are you filtering out? Is it working, right? Like you have then that raw view of the events that are coming through the streaming event source, and you can compare and contrast and see what they look like.
So now I'm gonna interrupt you. We probably ought to go back into it because we have a lot coming in. So and some good ones coming in here.
Yeah.
First of all, I would say, just if you're not familiar, DynamoDB streams, as you put stuff into DynamoDB, it has a stream that comes off the back, and under the hood that is Kinesis, right? So
it's close. It's close. It's not
getting crazy with that statement.
But it's very similar.
Okay, very similar. There you go. So, but the filtering works.
Yes.
The same. Okay. All righty. So going back up here real quick. First of all, there's a lot of focus on your bike, Adam. And so we love the road bike. Appreciate that. I feel less than. I have nothing but brick walls behind me, but whatever. Okay. So I had a question here. Can we see the log in CloudWatch for troubleshooting? You skip it if you're going to talk about it. So we did talk about analytics. What is available in there? Do y'all know?
Yeah, so today there's really not much visibility into how much has been filtered out, whether something has been filtered out. And that's really why I recommend this kind of 2 Lambda functions subscribe to the same event source strategy, because today there isn't a metric that you can look at or logs that you can look at that say, here's everything that was filtered out, right? So that's not there today, and so that's why I recommend that we do it this way.
Can I throw an idea here about testing, because it just came to my mind that we don't have the metric, but we could look at how many records are coming into the stream. We have that metric, and then we might potentially in the Lambda function do some custom metrics or some embedded metrics format logging, and say I received 5 records and I received 100 records, and then it would emit some sort of a metric, and we can compare the two maybe and see like how much went in and how much came out. Just throwing ideas there. So,
but you could throw a quick alert on that too, right?
Yeah,
you
for
could
sure.
Say, hey,
for
yeah.
Sure.
So that's an interesting idea. I like
of course, but like you can create, even though there is no metric at the moment, you maybe can kind of create your own custom metric with embedded. Well, you can just emit metrics, of course, but the embedded metrics format is better.
Right.
So maybe that's one way around it. But I really, really hope that AWS will come up with the metric for this at some point.
I know someone who works there. I'll put in a good word. So his name is Adam. All right. Or Oathead or Mohawk. All right. So we have another question coming in here. It's this question from Twitter. It says event filtering will definitely save me costs on invocations, but for SQS source, the Lambda service will still pull regularly. So this is kind of a where is it billing? So am I still paying for the get message request?
I believe you are. You are, right? So this is kind of on the SQS side of the billing, right? There's like a charge for like polling the messages.
Right.
And yeah, I believe you're correct. You are still going to pay for that polling.
But not the invocation if it doesn't.
But not the Lambda
right.
invocation.
Yep.
Right.
Right.
Exactly.
All right, another one here. I told you we got quite a few here. How do filters impact data latency, or is there any impact?
Yeah, at least in my testing so far, not that I could notice. That's, with the caveat of like, I'm processing things with like my kludgy Python code. So I'm not, doing crazy low latency stuff to begin with. But I haven't seen any big impact, and we can look at the duration on these two Lambda functions and see if we notice anything. But I haven't seen anything.
All right, we'll grab one more here. We have another one on metrics, but I think we've talked about that. So here we go. It's another one from Mark. Is the SQS fan out also useful to avoid lost records with either event sources such as Kinesis?
So that same fan out pattern you basically can accomplish with Kinesis or with DynamoDB streams in the way that I'm showing here in the diagram, right? So with SQS, because SQS has like a single consumer, you basically have to do that fan out to individual SQS queues. Whereas with DynamoDB, this top Lambda function reading from this DynamoDB stream doesn't impact this bottom one at all, right? The data in this stream is immutable. It's not being changed as it's read, right? And so, yeah, it's.
I want to jump right on this one because I have had this question like for some time now and thinking about how this works, and I think this is an appropriate moment to ask it. Because you said the Lambda on top doesn't affect the Lambda on the bottom. And the question is well, I will ask about Kinesis, but I guess the same applies for DynamoDB streams. But imagine we have like 3 Lambda functions that are acting as our stream consumer. And let's say that they are kind of filtering out their specific messages. So like each gets the subset, of the whole. But are there still going to be like 3 stream consumers in that case? Because, well, we know that the amount of consumers that we can have per stream or per shard is limited because there is a limit for get records API, for example, and there is also the 2 megabytes per second per shard limit for reading from the shard, or from a stream. So basically, the question is, where does this limit apply? Does the limit apply before filtering or after filtering? Will my 3 consumers that basically kind of only get the subset of data, can they still throttle the stream or not?
Yeah, so those 3 consumers, those 3 Lambda functions, think of them as 3 stream consumers, right? Because they each have their own polar. And in that, the sort of necessity of that, at least and this is like out of my head in terms of like why I think this is the case. Like, but basically you could imagine one of those Lambda functions could be super fast, right? And finish in 50 milliseconds and, just process everything super, super fast. Whereas another Lambda function might take a really long time. And so because of that, after a little while, they could be reading from very different points in the stream. And so they each have their own polar to understand where they're at and to not be kind of mixing that up or kind of impacting one another.
So but basically with filtering, you will also have each Lambda as a separate consumer because like the polar is separate and like each polar still gets the up to 10,000 records per second and all that kind of, and up to 2 megabytes of data per second. So basically, if you want to have more than 2, like if you have this routing scenario where you want to route to different Lambdas based on different filters, which I think is very neat. I would do that. And in that case, instead of having like one huge monstrous monolith Lambda with all the if else's, I would do like separate smaller Lambdas with
Yes.
filters. But if you have more than two, then you probably should use the enhanced fan out, right, with Kinesis.
Exactly. And that's just another side. And then I'll go back to the demo, because we're going into the weeds, but I kind of love going into the weeds. Dynamo, has a limit of 2 stream consumers on DynamoDB streams and doesn't have the enhanced fan out option. But DynamoDB last year shipped a feature where you can, instead of having DynamoDB streams there as basically the change log for Dynamo, you can have Kinesis. And so if you do have that use case where you need more than 2, you need 5, 10, something like that, you can have DynamoDB push those changes into a Kinesis data stream and then use enhanced fan out. So nice option to have there.
If you're not familiar with enhanced fan out, we sometimes we throw some words around. I wrote a blog on this as well. I was telling the folks here, this is probably one of the first blogs I wrote at AWS, but on what's enhanced fan out. Somebody just asked the question. I wrote a blog that explains enhanced fan out and what it does. It allows you to add more consumers rather than attaching directly to the stream. You attach to a consumer, which gives you more. You can. It's faster and it allows more consumers on there. So if you have questions on that, I just posted that. And let's jump in and see what we got.
All right. So let's switch over and walk through a little code here. Hopefully that's big enough, but if not, let me know in the chat. So, to match my sweatshirt, I did this in SAM. So I got a little SAM template here that does a few things. So, basically we have 2 functions here. We have an unfiltered Lambda function, right? So simple Python function, which I'll walk through in a minute. And it's hooked up to the DynamoDB stream as an event source with a batch size of 3. And then we have the second filtered function, which has basically all the same setup until you get down here. And there's this magical section right here, which is the filter criteria. And so what I've done here is I've created a filter criteria and I've set the pattern up to match basically items that are removed from DynamoDB by the TTL, the time to live process on DynamoDB. So DynamoDB has this option where per item you can set a time to live value, and basically DynamoDB, the service in the background, will remove those items, when that time comes up. And so what I'm doing here on my filter one is I just want to see those items that were removed by TTL. So I don't want to see the new inserts of new items. I don't want to see updates. And I don't want to see any user deleted records, right? So I could do a user-based delete and it wouldn't show up here because I'm not only looking for the event name to be removed, but I'm also checking the identity of who does that removal. And so for TTL removed items, it's this DynamoDB Amazon.aws principal ID. And so that's that piece there. I created a DLQ because, if there's a problem with my code, I don't want to lose data. And so if my Lambda function errors, it's going to drop those to a DLQ. And then here's the DynamoDB table definition. So I create the DynamoDB table. It's got a UUID as the hash. And then I have this attribute. I'll put it in here. It actually doesn't. It needs to be in here so that I can specify it as that TTL attribute. So you basically tell DynamoDB what attribute in the item you want it to use for the TTL value, and then you can set it per item. So pretty cool. And then, of course, enable the stream. So I need to enable that stream. So so I've deployed this, and I'll just show you the Python code for the Lambda function itself is really straightforward. I'm really not doing much at all, but I am using Lambda power tools, and I am doing, and I hadn't shown Anahit this code beforehand, but I love that Anahit, we both do a lot with Kinesis, and she thinks the same way I do. I added a custom metric using Lambda power tools that is the number of records processed, right? So that we can look at that custom metric and say, oh, like this is how many records we processed in the unfiltered one, and here's how many records we processed in the filtered, right? So just giving ourselves some more visibility. If anyone hasn't seen Lambda Power Tools before, there's Lambda Power Tools for their open source projects. They're out there for Python, Java, and then TypeScript just launched in preview. And these are basically just utilities for Lambda to make things like logging, X-ray tracing, creating metrics. A lot of those kind of utility things, they just make it a lot easier. And so that's why I'm using it here. So this first,
Adam, I'm going to jump in real quick. If you're new to Power Tools, Adam just covered a lot of it, and they're great. But we had a great covering. We just did Power Tools last week on Serverless Office Hours. So I'm posting the link in here so you can go back and watch that. And Sarah, join Julian and take a look at it here. I'll post the link, and I'll hand it back to you.
Cool. Yeah, and so I have this function here where I'm just logging some metadata, right, like the number of records in the batch, and some other pieces. My process record in this case is the simplest hello world of processing records ever, right? All I do is print the record, and that's it. But I do just want to point out, like, this is just a good way to structure things in terms of kind of catching errors, right? So errors in streaming Lambda functions and in Lambda functions that are consuming from a stream really matter, right? Because if you kind of don't handle them and don't set up kind of your handling of retries right, it'll kind of just get stuck trying to process that same thing successfully. So you want to think about both your code and the configuration of the event source, when you do that. And then over here, now we get down to the actual handler itself. So I'm capturing a cold start metric using Power Tools. I'm tracing with X-ray and just using this logger to inject the Lambda context. And then here's the Lambda handler itself. And it's basically just going to loop through all the DynamoDB records, call that process record, right? And if it has any error, it's basically fails. And I'm going to log it and error out my Lambda function to allow the Lambda error handling that I've set up to work. And I'll just point that out in the template because this comes up as a question a lot. So, in the properties of my streaming event source, right, I've said that the maximum record age in seconds is basically 10,000, and the max retry attempts is 3. And so it's going to take those, and then I forgot to add in the actual DLQ part of it, but what it should do is push them to the dead letter queue. So like that, you want to make sure that you take a look at that and set that up. So let's flip over to the console. So over here, we have the unfiltered Lambda function. And let me just refresh the CloudWatch metrics here. And we can see, it's kind of spiking up to being around kind of high point here of 190 invocations. The duration average is right around 2 seconds. Thankfully we're not getting any errors, right? And then we'll go over to the filtered side of things here and refresh these metrics. You see the invocations is a good amount lower. The average duration is basically the same, right? It's not taking any more time, but we're not seeing as many invocations come through there. And I'll bring up the logs here. So these are the logs on the filtered function. And if you look at the logs on the filtered function, every one of these events that comes in, you're going to see that the event name is remove, right? So it's a delete. And then if you look down here, this user identity is that principal DynamoDB piece there as well. So that's how we know it's a TTL. And any of the ones that we look at here, they're all going to be those removes. They're all those TTLs, where if I go over to the unfiltered function and I bring up the CloudWatch logs there, over here, we'll still see those same removes as well, but we should also see a bunch of inserts like this, right? Which is inserting a new record. And so, it's getting everything, including the inserts, including the deletes. I just realized I didn't share the code that's actually writing to DynamoDB, so I'll show that. So I really like coffee. I loved the thing that Eric and his team did at reInvent with the serverless espresso. So I thought of this could be streams from new coffee locations for serverless espresso. So I'm kind of randomly choosing one of the cities that the three of us are from, and then randomly choosing a drink that gets kind of pulled into this item that gets generated and then written in a batch out to DynamoDB. So, just a kind of boring little script, but it's I guess one of the important pieces. The TTL value I'm setting everywhere is basically just 30 seconds from now. So I'm not keeping these for long, right? You could imagine this as a use case for a DynamoDB table that powers like a real-time dashboard, right? So you might be looking at like what's being ordered right now, but you're not keeping those items kind of long-term, but maybe you do want to capture that data, somewhere else in S3, something like that. So you could do something like this.
When you said coffee and you were looking at the code, literally my head went to CoffeeScript. I was like, that's how I'm dating myself there. I'm like, you using CoffeeScript? Oh my gosh. But okay, go on.
No, all Python for me for the most part.
Yeah.
So I'm just kind of constantly throwing, that's what this is down here in the terminal. I'm just kind of constantly sending these batches of items to Dynamo. So bring up the Dynamo console to just show that as well. So here is, the metrics for the Dynamo table. Make that a little bigger. Oh, that didn't want to close that. And so, here's my writes. Yeah, nothing crazy, but a little more than a write a second happening there. Going into that Dynamo table. And so, hopefully this is helpful. You can use this style of a setup to kind of test and play out with the event filters. This works great as well with the new SAM Accelerate feature, which allows you to basically like test real time within AWS, right? So you can simulate like a single DynamoDB record kind of going into a local Lambda function, but to really be testing out this filtering functionality, you really need to test in AWS. But with SAM Accelerate, that kind of inner loop of the developer experience of like make a code change, test it, make a code change, test it, gets much faster, even if you're, testing in the cloud. So, works really well with this.
If you're not familiar with SAM Accelerate, I'm posting a blog on that as well. If you're using SAM and you're not using SAM Accelerate, you're going slower than you can. So I encourage you to check it out. Good call out, Adam.
Cool. And so that's kind of my demo in a nutshell there. Do you have other questions we should talk through, or?
Oh, yes. yeah, we've got questions. So, all righty. So let me jump back a little bit here. One, Kirk's doing a great job. No SQL, know how. He's been keeping up with us and he's our DynamoDB expert and has posted stuff. And one of the things he said, and something to be aware of, if you go with this pattern that Adam was using, is DynamoDB TTL does not necessarily remove items exactly when the time passes. It's not a boop, but the capacity use is free, but is excess on the service and can vary. So it will clean out. So don't, if you need absolute accuracy, this isn't the way to go. If you need things just to roll off because they're stale, this is the way to go. TTL is very handy, and I appreciate that you calling that out. Okay, so a couple of things. One, there was a call out on how they love TTL. Didn't know that existed. So excuse me 1 second here. I had more questions, but I got to go back up here. All right, so sorry. Give me a moment. Okay, here we go. Hi, everyone. Just here we go. Let's see. These annotations are okay. I answered this one in there. So sorry. I think we might actually be okay. I thought we had more. You know what, Adam? Maybe we did answer them. I thought there were more. Okay. No. Here we go. Yeah, I just hadn't gone up high enough. Okay. So we have this question, and it's one of the patterns you showed. It says, when should I use Eventbridge instead of SNS in that diagram?
Yeah. So that's a great question. Maybe I'll bring that diagram back up and can talk to it. So when you should use Eventbridge instead of SNS in that diagram. Eventbridge is really nice if you want to do kind of complicated filtering and pattern matching on the events that are flowing through. So SNS supports event filtering, but it's only on top level attributes. Whereas Eventbridge, you can filter on the entire JSON payload of the event. Eventbridge also has some additional features that SNS doesn't have, like archive and replay. So talking with a lot of enterprise customers who are looking at event buses, they have that use case where they might want to go back and replay an archive of messages that went through their event bus over the course of an hour or 2 hours, and look through those messages again. You can do that with Eventbridge. SNS doesn't have that ability today. Places where SNS shines are really, really wide fan out, right? So SNS supports a number of different endpoints, whether it be email, SMS messages to phones, or webhooks, and you can in the thousands, tens of thousands, fan out to those. Whereas Eventbridge has some kind of lower limits there in terms of kind of how big that fan out can be. So hopefully that's helpful in terms of kind of choosing which you use there. But yeah, Eventbridge is awesome, very powerful filtering. And so definitely recommend checking that out as well.
We had a LinkedIn user that's, I don't know if you know them or not, LinkedIn user. Regarding the previous topic, so calling that out is would love to have the archive replay feature in SQS. So yeah, same kind of thought process there. All right, Franklin asks, can you set up 2 event filter definitions for the same SQS that trigger 2 different lambdas?
Yeah, so you really need to use this fan out pattern to do that. And the reason is that the kind of paradigm behind SQS consumption is a single consumer, right? Yep. The idea behind SQS is you pump a bunch of messages in there, and there is a single consuming application that pulls that. That single consuming application could be multiple servers, could be your Lambda function, but multiple concurrent Lambdas. But the idea is that it's a single application consuming it, and that each message is only processed once. And so if you want to be processing that message by 2 different applications, what you do is this type of fan out here using like SNS or Eventbridge, so that each one of those applications has their own queue that they're reading from.
All right, on. Okay. You have anything you want to add on that? You good with that? Do you like Adam's answer?
Oh yeah, for sure.
Okay. All right, good. All right, Adam, you passed the test. That was good. Glad to see that. Okay, we had a couple more come in. Going down here. Okay, again, asking about the power tools. Sorry. Okay, I think we just answered this. Yep. Okay. I think that here we go. So just to throw out there, DynamoDB plus TTL plus Lambda event source filtering is like chocolate and peanut butter. So we do have this one. I'm going to take it unless one of y'all wants to take it. This is it feels wonderful to be a granddad. If you don't know, last Monday my first grandson was born. They pretty much shut down the hospital after that. You're not going to do any better. So he was born. His name is Ryder Daniel Johnson. I have not held him yet. I was not allowed to go into the hospital because of COVID. We're not allowed to. And then I told these folks I was diagnosed with COVID, and I have COVID right now and could not go see him. So I'm isolating in my basement. I feel okay. I feel better than I have. But so soon I'm going to hold him. He's already saying my name. It's crazy. There's been a big debate about what we should be called. Thank you very much for the congrats. My dad was Papa. I think I might be Papa. There has been a rumor about someone saying my wife is Lolly and I'm Pop, so we're Lollipop. I don't know if we're going to go with that yet. So now let me jump back in. There are a couple more questions that are actually non-granddad related, so whatever. But I'll throw that out there. It says, I know there's a limitation on filter pattern for DynamoDB streams and numeric comparison. How would it be modeled to check something like age greater than 10? Wow, let's just throw this out.
I would have to look at the event pattern to see how that would work. I don't know off the top of my head on that one.
Okay. All righty. Any thoughts, Annie?
Yeah, I was just thinking, I remember that there are some numerical comparison operators there that you can write that like numeric and 10 and greater than, or age greater than 10. It's pretty straightforward, actually. I think, but I don't remember from the top of my head the exact syntaxes of that.
The good news here is that it is the same syntax as Eventbridge. Yep. So, like in kind of like searching for answers, you can look at Eventbridge blogs too, because if there's a pattern that works for it in Eventbridge, it'll work here as well.
So I am posting a blog post, and you have a blog that you wrote that kind of goes deeper into error handling in Lambda, right?
Yeah, well, it's a series of 2 blog posts about kinesis in general. And the second part is about consuming the kinesis stream. Well, first is about producing, and the second is about consuming. But in the consumption part, there is a lot of details about how, because Adam was mentioning about how crucial the errors or error handling is in kinesis, because it can pretty much ruin everything for you if you don't do it properly. So you can go check it out. There is a lot of details on what you can actually do, what happens there, why it happens, and what you can do when it happens. So that might be useful.
All right, and I just posted part 2, and does it link back to part 1?
Yeah, there should be cross links everywhere.
Excellent. Okay, yeah, so I just posted that. So yeah, there was a statement here. It's your example has tier pressure greater than 32. I don't even know what that means. Is this referring back to what y'all were talking about?
Yeah. So
okay,
they're pointing out that, and they have a good thing. The pattern in the blog is actually a numeric comparison. So
okay, nice.
So there we go.
People are paying attention. It's always good to see. You're like, did you have slides up? Yes. So great. That's great.
Very good.
Well, Adam and Annie, it's been great having you. We have about 5 minutes left. If y'all have anything you want to throw out, and I'm watching for any other questions coming in. But it's a fascinating show. I'm a fan of the filtering. I was so excited when it came out. Again, like I said, I have written so many Lambda functions that filter everything coming in and then do something, and it's great not to have to do that. So, and it's shameless plug time. You have anything you want to throw out and talk about?
Well, the blog post that you threw there, it's that both parts, they might be very useful for someone new to Kinesis, and I use it myself every now and then because I don't remember all the details. And then the course that I mentioned about, that's about plugs. And I was just comment about your comment about reInvent and how excited you were about filtering. I actually almost didn't notice this filtering announcement because I was so excited about the on-demand Kinesis at that point. I was like, that's coming finally. And then when that excitement subsided and I realized it's not exactly what I was hoping for yet, it's probably not the Kinesis serverless I was looking for yet. And then I noticed the filtering and I got very excited about the filtering because as a developer, it gives you so many new kind of ways of doing things and ways of deleting code, which is like the best thing ever. So
totally.
And that's what I was going to touch on too. Yeah. My mantra has always been configuration over code. My code, Adam, you made the comment earlier of kludgy code. Man, I excel at kludgy code. I will have a contest with you on kludgy code. And really honestly, and I've said this 100 times, the most brittle part of an application is going to be Eric Johnson's code anytime. And so anytime we can move that kind of stuff out to a configuration that is it either works or doesn't, you know what I mean? It takes away a lot of that ambiguity we really need to. We had a question, and they asked it earlier, and they're asking it again, just so you know. The question was, is this going to be supported in Kinesis Firehouse? We don't talk about future roadmaps on the show because we don't have any information on that. So I wasn't ignoring your question. I just don't have your answer. But we can hope, right? So thanks for asking. I appreciate that. All right. Looks like you have a fan there. Good job, Adam. And of course your bike, Adam's bike. I told Adam I was extremely jealous of hair, so hair on the bike. So, all right, Adam, you have any shameless plugs you want to throw out before we end?
I'm trying to think if there's something I should plug, but I don't think so. But hopefully like filtering and streaming Lambda. Hopefully, I'll be speaking at summits or reInvent or something sometime soon. So be on the lookout. I'll tweet out anytime that I'm going to talk about that stuff. But I love this topic, so feel free to reach out if you have questions or just want to talk about whatever having to do with Lambda and streaming. It's one of my favorite topics.
Awesome.
Me too. So same words from here. So if anybody wants to reach out, I'm always glad to chat about this or other topics.
Both of your, I don't mean to interrupt you. I'm sorry. I was just gonna say both their Twitter handles are here on their labels. So reach out. I encourage you to follow both these folks. Obviously, the bright lights in the room. I'm here to, I just ask the questions. So definitely I'd follow them and we thank you for joining us. And once again, next Tuesday, we will be back and you'll be seeing announcements about what we'll be talking about. Julian is wrangling that up, and Julian, I have seen him answer quite a few things. Thanks for being on with us, Julian. I appreciate that. With that, we're going to say bye. We'll see you next Tuesday, 10 a.m. Pacific. Thanks for joining us. Anahit, Adam, thank you so much. Great show.
Great talking
Thank
with you all.
you.
Thanks everyone for joining.